Yes, good morning guys to all of you. Please tell me, am I properly audible and visible? Yes. So guys, I welcome you all in this wonderful session. This is the third mock test we are conducting for BARC 2023. And today me and Chandra sir would be taking the entire 50 questions which you are expecting 50 questions in 60 minutes. So I would be taking questions from the areas of design and production, means strength of material, mechanics, then theory of machines, machine design, industrial engineering, production technology, and then Chandra sir would be coming for the questions for fluid and thermal part. So in that way we are going to cover the entire syllabus. And guys, this is some detail about me, those who are watching me for the first time. And then my dear, this is about the Telegram channel. You can join my Telegram channel, that is Mechanical by Dheeraj Sardana, to get the all important details, PDF of the sessions and the link of the sessions whatever are conducting. And guys, this is about the Mega Mock Challenge, and you know, from 11th to 17th of November Mega Mock Challenge 3 is live. You can appear for that. The link is there in the description. You can download the app and appear for this, and this is free test, 65 question, 100 minutes, similar to GATE. Syllabus will be manufacturing, material science, industrial engineering and IC engine. Okay, then my dear, we are talking about the questions without wasting the time. This is the first question in front of you from the material science, that is from the Gibbs phase rule. So for a metallurgical system, if the number of component in the system is 3, if the number of component in the system is 3, and then the maximum number of phases according to the Gibbs phase rule. So my dear, I feel everybody is aware that Gibbs phase rule is given as P plus F is equals to C plus 1 in case of material science, because in case of material science pressure is always constant, that is 1 atmosphere. So keeping that pressure into constant, we are having C plus 1. So guys, they have already mentioned, they are asking the number of phases, the maximum number of phases, and they have already told that the number of component in the system is going to be 3. So from that you need to solve it, guys. So you can write P is equals to, that is 3 is the component, plus 1 minus F. So my dear, P is nothing but 4 minus F. So guys, can you tell me what would be the number of phases? Yes, Rohan is saying the number of phases would be 3. Okay, Papa ka ghoda, good morning bhai. Okay, so dear, if you see here we have 4 minus F. Can you tell me what can be the minimum value of degree of freedom? Can you tell me what is the minimum value of degree of freedom? So do like and share the session, guys. Can you tell me what is the minimum degree of freedom? What is the minimum degree of freedom what is the minimum degree of freedom value? F can be what? At minimum, what you can have the value of F? Yes, Tushar is saying 3. So my dear, you know that degree of freedom is always going to be more than 0. है ना? 0 represent a space, 1 represent a line. Everybody remember that? So like that, if you are talking about F should be more than 0. So if F is going to be more than 0, and at the maximum F can also be 0. So when F will be 0, then my dear, when we are talking about the phases are going to be always less than or equals to 4. So my dear, if they are less than equals to 4, so the answer for this should be what? The answer for this should be what? 3 or 4? It should be 4 now, because it can be less than or equals to 4. So they are asking the maximum number of phases. Is it clear or not? Is it clear or not? What you are saying is as per the formula P plus F is equals to C plus 2. Okay, you are saying as per this formula, I feel so. This you use in the thermodynamics. Is it clear for everyone? Yes. So the maximum number of phases will be 4. Moving to the second question. This is from the material science, the defects. Tell me, this is when a pair of cation and anion absent from the crystal. It is called surface defect, line imperfection, Schottky defect or Frankel defect. Arey Rohan, that question is from material science. You have not studied the statement. They are saying for a metallurgical system, degree of freedom is not theory of machines. Degree of freedom is it is a physics which can be used anywhere. That is from material science, na? So in material science, thermodynamics, degree of freedom is different. That is Gibbs phase rule. It is not about the degree of freedom in motions. So guys, what would be the answer here? A pair of cation and anion. A pair of cation and anion. What would be the answer? So Tushar is saying C. And I would like to say the answer of Tushar is correct, because when we are talking about cation anion, means like Na positive Cl minus. So when we are talking about the ions in the ionic solids, the defect found is the Schottky defect only. And those who are saying Frankel defect, in the Frankel defect you are going to have a atom plus vacancy. So that is different than the Schottky defect. Okay. So answer will be C for this. Next question guys. Very good. Sai Ram Abhishek. बहुत बढ़िया guys. Moving to the next question. A mold sprue 20 centimeter long and the cross section area at its base is 2.5 centimeter. This is 2.5 centimeter square. The sprue feeds a horizontal runner leading into the mold cavity. Volume of this, then required time to fill the mold is. You know that required time to fill the mold is. This is going to be nothing but that is volume divided by AgVg. And you know Vg is nothing but 2ghm. From here you will find out the velocity and put the values in the formula. You will be getting the answer. They have already mentioned that this is the hm value. They have already mentioned this is the Ag value and this is the volume. They have also mentioned take G as 10 meter per second square. So what would be the answer for this? Rohan, Tushar, Sai Ram, Papa ka ghoda. Tell me the answer guys. This is a numerical from the casting. Okay, so Rohan Mandal is saying the answer is B, 3.6 seconds. Okay, so what about others? Very good, very good, very good. What about others? Yes, Mani is also saying B, very good. Sai Ram, Abhishek, Tushar, Papa ka Ghoda. What about your answers? And do like and share the session guys. As per my promise today, me and Chandra sir would be taking the entire paper. B is the right answer. B is the right answer. B is the right answer. Very good. 3.6 second. Tushar, I feel you have done some calculation mistake. When you will be going for Vg, I have done the calculations for you. Vg will be coming out to be 200 centimeter per second. It will be coming 200 centimeter per second. And when you will be putting this value, Tf will be coming out to be 3.6 seconds. Answer will be B for this. Okay. Moving to the next question guys. So we have already done, this was question number 2, question number 3, question number 4. This is question number 4. Yes. Okay Tushar, no issues. Two metallic sheets, each of 2 mm thickness, are welded in a lap joint configuration by resistance spot welding. A spherical fusion zone is created extending up to full thickness. Okay. So you are having, this is 2 mm sheet, this is 2 mm sheet. And they are talking about the weld nugget. They are talking about the weld nugget and they are saying weld nugget is spherical in shape and extending up to full thickness. So from that you can say the radius of the sphere will be 2 mm. Okay. So my dear, then they are giving you the data. So you need to find out the calculate total heat required. So I feel you know, first of all, we need to find out the volume of nugget. That is 4 by 3 pi r cube. And then you can find out the mass of nugget. That is volume into density. And then my dear, you need to find out the heat required. That is nothing but mCp delta T plus mass into latent heat. So that is what you need to do. This is the question from welding. Yes. So if you notice now, every test I have taken the questions from different topics so that everything can be covered. Okay. So guys, you can solve this question. And after that, we will be moving to the other questions one by one. Okay, this is question number 4 going on. Yes, Sai Ram, Tushar, Papa ka ghoda, money, Rohan. Solve this question. This is calculative. And do like and share the session, guys, so that others can also join it. On your request, I am consecutively coming for the third test. And if you want, we can also have one more test before your exam. Because today is, I feel, 17. So we have one more day. Questions are, papers test is from 18th to 24th. What would be the answer, guys? This is the density given, delta T given, latent heat of fusion given, and Cp is also given. Money is saying the answer to be A. What about others? This is question number 4. Money is saying the answer is A. What about others? Yes, Sairam, Tushar, Papa ka ghoda, Rohan. Okay, Papa Ghoda is also saying A and the answer is A. When you will solve it, you will be getting 351.75 joules. Take care of one thing, that when you will put the values here, latent heat is given in kilojoules. So you need to convert that into joules. Okay. So if you will be converting them into joule, you will get the right answer. Because you can see this is in joule, whereas this is in kilojoule. So that you need to convert into joules. Very good, guys. Very good. Moving to the next question. Question number 5. This is from sheet metal operation. So guys, this is from sheet metal operations. This is from sheet metal operations. So a cup is drawn as shown in the form of a circular blank of diameter D. And you can see the blank diameter they are asking. It is a simple formula if you want to make this shape. Sheet metal operation. So you know that we just need to equate the surface area of this blank. Like you will write pi by 4 capital D ka square. This will be equals to first surface area is this pi by 4 D1 ka square. Second surface area is of this curvature, that is plus pi D1H, and next surface area will be of this section, this one. So you would be writing plus pi by 4 D2 square minus D1 square. What would be the answer? What would be the answer, guys? This is question number 5. Yes. Abhishek, Tushar. Okay, fine. So guys, when you will be solving this, first of all, pi will go from everywhere. And when you will be cancelling the 4, here 4 will be coming in multiplication. Here this D1 square and D1 square will be getting cancelled out. So I feel you would be getting D as equals to what? Sorry, this option is D2 square. This option is D2 square. This is a misprint. Okay. So you would be getting D2 square plus 4 D1H. B would be the right answer. B would be the right answer. Okay. Is it clear? So this was a misprint, I feel. That's why you have done the mistake. B is the right answer. Moving to the question number 6, guys. Moving to the question number 6. This is a good question from rolling. Yes, they are saying in rolling process, the diameter of rolls is decreased by 20%, whereas coefficient of friction increases by 10%. The percentage change in the maximum reduction. For that, the hint is the maximum reduction is given as mu square R. So you can see R is decreasing, mu is increasing. R is becoming 0.8 times of R. Mu is becoming 1.1 times of mu. And you need to find out, first of all, this is the delta H new minus delta H old divided by delta H old into 100. That is what you need to find out. Okay. So by looking at the option, okay, very good. Rohan is saying the answer is C. If you are getting negative value, it means it is a decrease. If you get positive value, it means it is an increase. So Rohan and Papa Ka Ghoda have given the right answer. C is the correct, 3.2% decrease. Because you will be getting minus 3.2%. So minus means decrease. Very good, Tushar. Moving to question number 7, guys. This question is from metal cutting. This question is from metal cutting. And here they are asking you the coefficient of friction. No, they are asking you the friction angle. So you know, whenever these data are given, we will be using the formula mu is equals to F by N. Okay, and I feel everybody is aware about the formula of F and N. You need to put the value of F and N and you will be getting this, and you know mu is tangent beta. Mu is tangent beta, so this will help you to get the beta. Okay, if we have the data, we will never go for the formula like this, 2 phi plus beta minus alpha. That will be used only if we cannot calculate with these ways, because this is the condition of optimum power. Every time we may not be working at optimum power. So this is the theoretical data. This is the experimental data. So tell me what would be the right answer for this. So it will be Fc sin alpha plus Ft cos alpha. Everybody remember the formula? Anybody have given the answer? This is F by N. F by N. Yes. So Fc cos alpha minus Ft sin alpha. You will get some value. From there you can find out beta. Okay, Tushar is saying D is the answer. Once again recheck it. What you are getting the value of mu? Are you getting the mu to be 0.614? Are you getting the mu 0.614? They have given you the cutting force Fc. Ft is there. Yes, Mani's answer is correct. The answer will be 31.5 degrees. Very good, Papa Ka Ghoda. Tushar, you understood your mistake. Tushar, you understood your mistake. Abhishek, very good. So answer will be B for this. Rohan. Very good. Moving to question number 8. This is from economics of machining. They are saying in a metal cutting process, optimum speed in production rate is V1, profit rate is V2, and minimum cost is V3. So then what is going to be the correct one? Yes. Question number, we are having this as 8. Question number 8. So guys, we will plan one more test tomorrow, just one day before your exams are starting. Okay, so guys, you would be aware of that. The velocity in maximum production is more than velocity in maximum profit is more than velocity is minimum cost criteria. So answer for this is going to be B. So moving to question number 9. This is, you need to find out the rate of metal removal, MRR. You know MRR formula is FDV. FDV. Solve it and get the answer. Question number 9 it is. This is easy question. Easy question. Yes. Rohan is saying C, Mani is saying C, and I feel you will be getting 60,000 mm cube per minute. This is 50 meter per minute. So we will convert it into mm. 50,000 Depth of cut is 1.5, speed is 0.5. So when you would be solving it, you would be getting it as this is, okay, this is F, this is D, this is V. So when you will be getting it, 60,000. Is it like that? Is it like that? So I have not done the, okay, I have done the calculations directly. So C would be the answer. You will apply the formula accordingly. Okay, so I am deleting it. Otherwise, some students may be saying calculations. So answer will be coming as 60,000. 60,000 mm cube per minute, because in the last I have not shown the change of calculation. Then students are saying, sir, you have not done the change in the units. So that's why I am directly writing it. Yes, this is about EDM. EDM process. They are asking you the average power. They are asking you the average power. So I feel you know power formula is half CVD ka square divided by the cycle time. This is going to be the formula. Okay, this is from non-traditional machining method. Okay, and I feel you know cycle time is RC ln VD by VS minus VD. Okay, so this is the formula. Is it clear? Here it is VS by VS minus VD. VS is supply voltage. So this is VS. This is VD. This is R. This is C. So you need to find out the final answer. Solve it, guys. This is question number 10. Question number 10. Don't worry, there are other questions where less calculation is there. So every question is not that much calculative. So don't worry about that. Solve this. Whenever you find this type of question in the exam, always solve them in the last because they are very calculative. You can see you need to calculate. Yes, Rohan, 290 will be the right answer. B is correct. So 290 will be the right answer. Very good, Rohan. Very good, money. Everybody, guys. Moving to the question number 11. This is about the workshop. So on 16th of November, that is today only 7:30 p.m. there is a workshop for GATE 25 aspirants that will be taken by Richa Gupta ma'am. Strategy to conquer GATE 2025 in first attempt. Okay, and guys, you can download the app to get the free quizzes and all. Very good, Abhishek Sahu. So this is the next question, guys, and this is question number 11 from the metrology. This is from tolerance sync. They are asking you the value of L4. They're asking you the value of L4. So you can write L1 is equals to L2 plus L3 plus L4. Now you know that whenever you are finding out this, if you want L4 max, L4 max will be nothing but L1 max minus L2 minimum minus L3 minimum. Similarly, when you are finding out L4 minimum, it will be L1 minimum minus L2 maximum minus L3 maximum. Okay, when I am writing this, whenever this type of questions are coming, you need to find out the two limits and that will give you the correct answer. So what do you feel the right answer for this question number 11? Okay, Rohan is saying D is the right answer. 13 plus minus 0.06. Yes, Kumar S. Yes, Papa Gagoda, D is correct. Money. Moving to question number 12. Moving to question number 12. This is from NCCNC. This is the easy question. Like no calculations are involved. If you know about G codes, you can directly answer it. They are saying this is the starting point, this is the end point, this is the trajectory. So you are moving in this direction. This is clockwise. So you need to see which code is used for clockwise. Very good, Tushar. Which code is used for the clockwise? By that only you can answer this question. Question number 12, guys. Rohan is saying A. So my dear, first of all, G02 is used for clockwise and G03 is used for anti-clockwise. So just by looking at that, either A or B is going to be the right answer. That is for sure. C and D are wrong. Then my dear, they are showing you x120, y60 and radius 60. Here x60, y120 and radius 60. So you can see you are moving from this to this point. So x120, y60. This is your target point. So answer is A. Very good, guys. So moving to question number 13 now. This is the formula from impact factor, strength of material. Formula from impact factor, strength of material. Tell me the right answer for this. So this is no calculation involved. So that's why I said some questions are very easy. So just by looking at them, you can solve them. Yes. Tangi Siva is saying C, Mani is saying C. Yes, C is the right answer. Because you know impact factor is given by this. Okay, here H is the height, delta static, and this is actually delta L is the delta L. This is the delta L. Okay, static. Fine. So moving to question number 14, guys. This is actually the formula is coming out to be impact factor is equals to 1 plus square root of 1 plus 2h divided by delta static. So here delta is represented as delta L. Okay. So don't bother about that. Answer is C for this. Moving to question number 14, guys. They are asking you the maximum bending moment. First of all, you will find out the support reaction calculation, which is very easy because it is symmetrical loading. So L by 2, you can see this is two triangles. One triangle will be going to here, one triangle weight will be going to here. So you can find out RA and RB. Once you get RA and RB, you need to find out the bending moment here. Okay. So let us see how many of you give the right answer for this. Okay, so Tushar and Papa Gagoda have given the answer as C, WL square by 12. What about others? What about others? Very good. Rohan Mandal also said the answer is C. And guys, I would like to say that yes, the answer is C. First of all, you know the area of triangle is going to be half into W into L by 2. So based on that, you can see this area will be going to here. So RA and RB will be equals to this. Okay. Then my dear, when you will be writing the bending moment equation, it is going to be RA into L by 2 and that is the sagging moment and that triangle weight will be creating the hogging moment. So minus the area of triangle is half into W into L by 2 and that is acting at a distance of 1 by 3 of L by 2, that is L by 6. So answer will be coming out to be WL square by 12. That's correct. Very good, Mani. Very good, Rohan. Moving to question number 15. This is from bending. I feel you know bending stresses are E into Y upon R, where if you want the maximum bending stress, you need to put Y max. Question from the belt. Yes. Question number 15. 15 more to go. We have seen question of production. Now we are having question from strength of material, machine design, industrial, theory of machines. Kumar S is saying the answer is D. What about others? What about others? Tangi Siva is saying the answer is B. B is the right answer. So when you will be saying they are giving E to be 80 GPa, so 80 into 10 की power 3. Then Y max is, they are saying 0.4 mm belt. So if 0.4 mm is the thickness, Y max will be 0.2. Because if that is the belt bent like that, so neutral axis will be coming, neutral fiber will be coming like this. So this will be half of the thickness. Divided by, they are saying 30 mm diameter. So when you will be solving this, answer will be this. B is the right answer. Clear for everyone? I don't know what mistake you guys have done. Those who are saying D. B would be the right answer. Okay, because the formula for this is actually E into T divided by D. Okay, so answer will be coming out to be B. हाँ, okay, आपने वही गलती करी है जो मैंने करी है. 15 will be there because R is the radius. They have given you the diameter. Okay, so this is going to be 30 mm diameter. 15 will be coming. Yes, is it clear now? Everybody is getting B? Yes. So Neeraj, I feel you also have done the same mistake which I have done. But I am not going to appear for the exam. You are going to appear for the exam. 16. So they are asking you the maximum shear stress. So you know the formula for maximum shear stress is SA Y bar upon I NAB. The cross section given is rectangular in nature. For rectangular, this is D by 2, this is width. And they have said the shear stress at a particular section 1/3 of the depth of beam. So 1/3 of the depth of beam is this, D by 3. So I would like to say that if you are going to consider this area, this is for 1/3. So you know that tau is directly proportional to A into Y bar because all other factors are same for a given cross section because width is constant for this. So you can write tau 1 by tau 2 A1 Y1 by A2 Y2. So I feel everybody is aware for this case. When you are talking about the shear stress at a particular section in 1/3 is 120, the maximum shear stress is, you know, maximum shear stress is always found to be at center because the shear stress distributions are coming like this. So this you need to find out, this they have given to you. So this is 120, you need to find out what is this. Okay, so my dear, you know A1 Y1, you can take the first one which you need to find out and second one which is given to you. So you can write tau 1 by 120, 120 or 130, 120. So what is A1? You know that area will be this one. This is the area, hatched area. So B into D by 3. B into D by 3. Y1 bar is the distance of centroid from here. So this is going to be what? You know that this total one is D by 2. This one is D by 3. So you need to find out this distance. This is Y1 bar. So when you will be putting this value Y1 bar divided by the area for the second one is, I feel I have taken just opposite. You will be having first one area is B into D by 2. And when you will be considering this area, entire area, for this entire area, obviously at D by 4 will be the centroid. So it is D by 4. Then for the second area, B into D by 3. And that you need to find out the distance. Because you know this distance is D by 2 minus D by 3. That you need to add into D by 6. So you would be getting the distance. And that will give you the tau 1 as equals to. Very good. So Tangi Siva, I have said the answer to be A. What about others? What about others? So I feel you can feel it. D by 2 minus D by 3. It is going to be what? 3D minus 2D. It is coming to be D by 3. So D by 6 plus D by 6. It is D by 3. D by 3. So when you will be solving it, it will be coming out to be 9 by 8. So answer is 9 by 8 into 120. Answer will be 135. A is the right answer. Clear for everyone? Please tell me that. Clear for everyone? A is the answer. Everybody got it? Yes. Wonderful, guys. Wonderful. So do like and share the session. This is question number 17. This is question number 17. Here two springs are joined in series. You can consider two springs as two bars in series because they are subjected to axial loading. And you can consider the force acting like this. This stiffness is K, this stiffness is 3K. You know that stiffness is nothing but AE by L. AE by L. For first, for second. The question is saying, find out the strain energy stored. Find out the strain energy stored in the first bar. So you know strain energy is half into P into delta. So you will assume a support reaction here. If this is A, it will be RA. And one support reaction here, this is RC. So you know that RA plus RC is equals to F. And also you know that delta of 1 plus delta of 2 is 0. So you can write RA by K because stiffness is AE by L1 plus RC by 3K. That will be equals to 0. If anybody have any doubt, please ask me. So this two equation 1 and 2. Solving these two, you can get RA and RC. Once you get RA and RC, then the answer for strain energy will be half into RA into what is delta RA by K. That is going to be your answer. Okay. I feel this type of question I have done many times. Try to solve it. If you have any doubt, please ask. Arey bhai, you will assume it to be bars in series. Okay. Some student can also try this like taking them into the springs in parallel. You will get the right answer for 2 spring case, but for the 3 spring case, answer will not be coming correct. So you can consider them in the parallel, springs in parallel. You will get the right answer for this case. Okay. You can try that, but this is the correct way to do. If 3 springs will be coming, then only this will be giving you the right answer. Because in reality, they are in series, they are not in parallel. Tell me. Everybody. Arey bhai, when you will be taking the section here, okay, I have done something wrong, kya? This is not RC, this is plus, this is delta 2, na? So delta 2, when you will be taking the section here, it is RA minus F. RA minus F by 3K. Yes. Okay, so I am solving it for you. RA by K plus RA minus F upon 3K will be equals to 0. This will give you the value of RA. KK will get cancelled out. RA is equals to RA minus F. So it is becoming minus RA plus F. So when you will be taking it, RA will be coming out to be F by 4. So when you will be putting F by 4 here, you will get the answer to be F square by 8K. Half into RA is F by 4 plus, into f by 4k. So f square by 16k. Have we done something wrong? Yes, what you have got? B. Let me do this. I feel some mistake I have done. Let me check the calculation. So guys, can you see where I have done the calculation mistake? 3, it will be 3. Anybody? Some calculation mistake happened from my side. Because the answer you are getting is correct. You are getting the answer to be B. Okay, 2f in, okay. I have put it the value of force to be wrong. Sorry guys. This is going to be 2f. Fine. Now we will see what we will be doing. So it is going to be Ra by K plus Ra minus 2f upon 3k is equals to 0. K will be going aside. So you would be getting Ra barabar. This is 3 times Ra barabar. It is going to be minus Ra plus 2f. So you will be getting 4 Ra 2f. Ra will be coming out to be f by 2. So then you will be getting f by 2 here. Answer will be f square by 8k. D is the right answer for this. Yes, D is the right answer, guys. Now, if you have any doubt, I am telling you what to do whenever you get this type of case. If here k, then by parallel case you can give the right answer very easily because it will be equal. Okay. If here also k, you can say 2f will be divided f here. We need not to go for any calculation. But otherwise, the correct way to do this is you will be assuming 2 bars in the series, and you know that delta is given as force but a stiffness. So force in this member can be found out by method of section. To the left hand side it is Ra, to the left hand side it is Ra minus 2f. So when you will be putting this value into this equation, you will be getting the Ra as f by 2. Then putting this into the strain energy equation, you will be getting f square by 8k, which is the correct answer. I feel everybody understood this. If you have any doubt, you can still ask. This is question number 18, very easy to solve. So guys, this question is saying torque producing 1 radian twist in a shaft of unit length represent. You already know theta is TL by GJ. You just need to put the values of the given thing. They are saying theta is 1 radian. They are saying length in a shaft of unit length is 1. So they are asking then what is the torque for this shaft? What would be the right answer, guys? So guys, I feel you understood. Last question, I have done a mistake in putting the value of force. After that, the answer is correct. Very good. So you know that when you will be putting it, torque will be coming out to be GJ. So the answer for this is torsional rigidity. GJ is the torsional rigidity. Very good. Moving to question number 19, Mohr circle this time. Question number 19, Mohr circle this time. Question number 19, Mohr circle this time. So they are saying what is the major and minor principal stresses. So my dear, you can see they have given this thing as 50 and this total as 100. So when they have given the total as 100, for sure this half is 50. So that you can find out the radius. You can find out the radius. OA square plus OB square. Once you get the radius, you already know the center. Center is 50, 0. 50, 0, and you want to find out the principal stress 1. It is going to be 50 plus a radius. Sigma 2 is 50 minus radius. Because when you will add radius here, you will get sigma 1. When you will subtract radius here, you will get sigma 2. So these two are the answers of yours. Yes, so Chandra sir is waiting, guys. So he is in the queue to take your rest part. 19 question is going on. Still 11 questions are left. Answer for this is coming out to be B, 120.71 and minus 20.71. Very good guys. बहुत ही बढ़िया. Wonderful. You guys are doing very nicely. So guys, this is the question number 20th now. This is from theory of failure, machine design. For total strain energy theory ratio of semi-major axis to the semi-minor axis. If you remember in MSET, we are getting an ellipse. This is the semi-major, this is the semi-minor. So semi-major axis is SYT divided by square root of 1 minus mu. And semi-minor axis is SYT divided by square root of 1 plus mu. So my dear, you need to find out the ratio of semi-major to the semi-minor. Semi-major to the semi-minor. So semi-major to the semi-minor. What would be the answer, guys? What would be the answer? Semi-major axis to the semi-minor axis. Question number, it is 20th. अरे भाई रोहन, इतना ही सोच लो कि मेजर बड़ी होती है कि माइनर बड़ी होती है रोहन? मेजर इज बिगर ना, सो इट शुड कम ऑलवेज मोर देन वन एट लीस्ट. हाउ ए कैन बी द आंसर? Kumar S and Mani have given the right answer. Answer for this is going to be B, 5/3. Because this ratio will be coming out to be what? It will be coming out to be square root of 1 plus mu, 1 minus mu. So you will be getting the answer to be root of 5/3. B is correct. Moving to question number 21, guys. This is from fatigue loading machine design. Yes, fatigue loading machine design. In a machine component, it is subjected to variable flexural stresses 200 MPa and 150 MPa. So sigma max is 200. Sigma min is 150. Then which of the following is correct? Look, stress ratio is sigma min by sigma max. Stress amplitude is sigma max minus sigma min by 2. Range of stresses sigma max minus sigma min. What would be the answer, guys? What would be the answer, guys? Yes, Kumar S, Tengi Siva, Papa ka Goda, very good. Money. You can see, guys, when you will find out the range, the ratio, it is 150 by 200. It will be coming out to be 0.75. So first statement is correct. When you will be finding out the range, it is 200 minus 150. Answer will be 50. 3 is wrong. Stress amplitude is 200 minus 150 divided by 2. Answer will be 25. 2 is correct. So A is correct. Very good. Moving to question number 22 from reverts. What is the answer for this? 22. 8 more questions to go from my side, then Chandra sir will be coming. So you need to find out the number of reverts per unit pitch length. This is the per unit pitch length. Very easy question. Very easy question. Solve the answer, guys. Okay, Tushar is saying A. So my dear, okay. So first of all, generally students are thinking this is 1, this is 2, this is 3, this is 4 and this is 5. But dear, only half rivet will be coming in your per unit pitch length from all the 4 sides. Half plus half, half plus half. 2 plus 1. Total answer is 3. A is the right answer. 3 is the right answer. Very good, Biseti. Wonderful, guys. Moving to question number 23. This is from bearings. This is from bearings. So first you will find out the equivalent radial load, that is XVFR plus YFA into S. Then you know that L90 is equals to C by PE to the power 3 for the ball bearing case. And they have said this is ball bearing, so this is the formula. Yes, Biseti, good morning. How are you? So try to solve it, get the answer, guys. They're asking you the rated life of the bearing in million of revolutions. So C by PE. First find out PE. This is X. Y. This is C. This is FR. FA. Take this as 1 as it is not given. Solve the answer. So Biseti, I am happy to see you after so many days. Try to crack some of the exam this year. A lot of opportunities are there. Solve it, guys, solve it. Yes. Okay, Kumar S is saying answer is D, 8,000. Very good. Very good, Kumar S. Tushar, very good. Very good, Tushar. Money, very good. Answer is D, guys. You will get 8,000 million revolution. Moving to the next question. Question number 24. A 20-degree full depth involutes per gear module of 5 mm, 25 teeth is to transmit this much power. This is RPM, face width, the tangential force. I feel you know FT is 2T by mz. So torque will be coming from power is torque into omega. So from that find out the torque, put the value here, you will be getting the tangential force. Very simple. So guys, this is question number 24. Wonderful, wonderful. Great, Biseti. Dhalapatti is saying the answer is D. Papa Ka Ghoda is saying D. D is correct. First find out the torque. You will be getting the value of torque, and after that the answer for force will be 3819.7 Newton. So the answer is 3.82 kilonewton. Very good, Aftab. Money. Moving to question number 25. This is a break question. Okay. So this is a break question, and I feel everybody is aware how to do that. They are asking you the coefficient of friction 0.3 is given. They are asking you the value of A in mm for self-locking condition. You know, for self-locking condition, P is going to be 0 actually. P is going to be 0 actually. Okay. So you know that as this is the block brake is shown in the figure subjected to a braking torsional moment of 500 Newton meter. So they have already given you TB. TB is mu nr. So when you will be getting this mu nr, you will get the value of n from here. Normal reaction. You know normal reaction will be acting like this. Now you know ki this is normal reaction will be creating in this direction. This is anti-clockwise. So obviously as for self-locking P is 0. Mu n is going to balance it. So if it is going in anti-clockwise, the mu n couple should come clockwise. So mu n on the shoe should act like this. This should be mu n. So you just need to equate mu n into A is equals to n into 200. You will get the value of A. What is the answer you are getting for this? Very good question. You can see all the new types of question. Okay, in all the tests, I have come up with the new types of question. What is the value of A you will get? First of all, find out N from here. Braking torque is 500 Newton meter. Radius is 500 mm, so you can take it 0.5 meter. n you will be getting, mu is given to you. After getting n, put it here, you will get the answer. Yes, even you need not to calculate n, n will get cancelled out. So you can get A as simply 200 by 0.3. Okay, so answer will be A for this. Okay, answer will be A for this. Aftab, answer will be A. Even we need not to calculate n, n will get cancelled out. A will be simply 200 divided by mu. So 200 divided by mu. So I am directly solving, assuming that the concepts are known to you, because this is the mock test going on. Question number 26. Okay, this is question number 26 from industrial. After that, we will come to that question. Industrial 26. Here they are asking that what is the latest finish time for fifth? You need to find out the latest finish time for fifth one. This is the latest finish time. Yes, yes, yes. Try to solve it, guys. Try to solve it, guys. Till then, I inform to my paid course student that class will be today 10 minutes late. Okay, guys. So the answer for this is coming out to be what? Let us see. Some are saying B. Let us see how to solve it. First of all, we will be starting from here. This is 0, 0. So when you are starting from 0, this time will be 2 and this will be 3. 3 plus 2 will be 5. No, here you need to see. This is giving you 3 plus 2, 5. This is giving you 2 plus 7. 2 plus 7. 2 plus 7, 9. Okay. So it is giving you 2 plus 7, 9. So my dear, it is giving you 3 plus 2, 5. So I feel you will be having 9 here, because the bigger of this 3 and 9 is 9. So you would be having 9 here. Then my dear, if you have 9 here, if you are going from here, 2 plus 4 is coming out to be 6. 2 plus 4 is coming out to be 6. But here 9. So you will be having 9 here. Then my dear, when you will be going to here, this is 9 plus 2, 11. But this is 9 plus 5, 14. And 14 plus 3, 17. So you need to take the maximum one, na? You need to take the maximum one. So when you will be going for back side, here we will be starting with 17. 17 minus 2 is 15. Similarly, 17 minus 3 is 14. So when the path is non-critical, there we are having the float. So answer for this is going to be D, not B. Got it or not? Got it or not? This is the wonderful question, guys. Moving to question number 27. Only 3 more questions from my side. 3 more questions from my side. 3 more questions from my side. Then Chandra sir would be joining for thermal and fluid question. Previous question was a good one, guys. Make it star. Okay. Moving to 27. A simplex method of problem solving after optimality is reached. The solution of a variable is 0. Then it is a case of unbounded, multiple solution, infeasible or degenerate solution. Yes, yes, yes. Only 3 more questions from my side, guys. If you find 1 to 2 questions difficult, it is there going to be in exam. Okay. So whenever we are having in a simplex method of problem solving, after optimality is reached, the solution of a variable is 0. Then it is a case of multiple solution. Okay, fine. So moving to question number 28, guys. In this question, a cantilever beam of flexural rigidity EI 81, it is given to us, is loaded as shown in the figure. The bending moment in the fixed beam is bending moment. So you need to find out the bending moment. I feel you know bending moment is going to be, this is 900. It is plus minus 100 into 9. What would be the answer? What would be the answer? This is, what would be the answer, guys? Very good, very good, very good. So guys, now I am in a little hurry because my paid course class was 12 p.m. So today I delayed because of this class. Okay, one last question from my side. A cantilever beam, the same loading is there. They are asking you the deflection at the free end. They are asking you the deflection at free end. So if this is A, this is B. So deflection at A will be deflection at A due to this load plus deflection at A due to the moment. So it is going to be minus PL cube upon 3EI plus ML square upon 2EI. So you just need to solve it and get the answer. This is the last question from my side. Everybody is getting B. 75 mm minus 100. Length is 9 meter upon 3 EI. 81 mega. So 10 power 6. Then plus bending moment is 100. Bending moment is 0. Sorry, this is 900 into L square. What is L square? 9 ka square upon 2 EI. So answer will be coming out to be, I feel 75 mm is correct. So guys, we have done the 30 question of my part. Okay, now Chandrasekhar sir would be joining for thermal and fluid part. So stay tuned here, and I will be sharing this PDF of the questions in that Telegram channel. If you find any difficulty, you can discuss with me in any of the question if you find. Okay, so then I will answer you there. So from my side, it's goodbye, and I will see if possible tomorrow also we will keep the last mock test of BARC before the exam. Okay, so goodbye from my side. Goodbye. Chandra sir is joining now.
Hello everyone. Thank you Dheeraj sir, and thank you guys for your active participation. First of all, please do let me know if I'm audible and visible to all of you. Can you guys hear me? So good morning everyone. Good morning all of you. Welcome to this session. You are already there. Please welcome me to this session. I hope everyone is safe and sound and have done with your enjoyment, festival enjoyment and semi-final yesterday. So back on track. So let us start. I am having the questions from fluid mechanics, thermal engineering, thermodynamics and its application, as well as the questions from heat transfer. There are 20 questions I'll be having. So let us start the questions. Yes, Renu, your doubt is with Dheeraj sir, right? So you can talk to him one-on-one. So if you are not part of my Telegram channel, please do join me on the Telegram by scanning the QR code, or you can search by the name Mechanical by Chandrasekhar, or use the link which is mentioned at the bottom. So keep your notebook, pen, calculator, keep yourself highly active. The more you solve the questions, as I have already told you, the more you participate, the more confidence you build. So there is the first question. Few questions are from the thermal engineering. Good morning, Maniket. Welcome. Welcome, Tushar. So the first question is from the basic thermodynamics. There are three Carnot engines which are operating between temperatures T1, T2 and T2, T3, T3, T4, which are arranged in series, each with 1 Kelvin difference in the temperatures. So which of the options is correct for the given question? This is question number 1 from my side. T1, then engine E1, then T2, then the next engine E2, then T3, then the next engine E3, then T4, and each one of them are having the difference of temperatures. What is the thermal efficiency for a reversible cycle? Carnot engine means reversible cycle. Reversible cycle. Carnot engine means reversible cycle. So thermal efficiency of reversible cycle is 1 minus T2 by T1, isn't it? That is the thermal efficiency of a reversible cycle, 1 minus T2 by T1. I hope it is clear. So the temperatures are having a difference of 1 Kelvin. If we assume this to be 4 Kelvin, then this will be 3 Kelvin. T3 will be 2 Kelvin and T1 will be 1 Kelvin, isn't it? So do you agree that T2 by T1 is greater than T3 by T2 is greater than T4 by T3, isn't it? T2 by T1, what is T2 by T1? That is 3 by 4 is greater than 2 by 3 is greater than 1 by 2, isn't it? 3 by 4 is 0.75. Do you guys understand this or not? T2 by T1 is greater than T3 by T2, isn't it? T2 by T1 is 0.75, then it is 0.66, then it is 0.5. T4 by T3 is 0.5. So because T2 by T1 is maximum, so efficiency of the first engine will be minimum, isn't it? Isn't it? So as T2 by T1 is maximum, so efficiency of first engine is minimum, then 2, then the thermal efficiency of the third engine. Isn't it? Yes, now people had given me the correct answer. Yes, Renu, Rohan, well done, Tushar, Maniket, Mani. Good, good, good. Option B will be the correct answer. Option B. So some of the question, there might be question in such a manner that you need to take some arbitrary values and then compare them. If you will try to analyze it without taking some arbitrary values, it will become difficult. Let us move to question number 2. Question number 2. The question is about the change in internal energy. 1 kg mass of air. Air can be treated as an ideal gas. And the mass of air is 1 kg. Expands reversibly from 65 bar and 0.0135 meter cube to a final volume of P1 is given, V1 is given, and final volume V2 is given. Polytropically with a polytropic index as 1.3. What is the change in internal energy? What will be the change in internal energy? Change in internal energy for an ideal gas is equal to m into Cv into delta T, isn't it? The process is 1 to 2. So can we say that is m into Cv for air into T2 minus T1. The objective is to find out the value of T2 and T1. Now we need to find out T1 and T2. How to find out T1? T1 is equal to P1 V1 upon MR. R for air. What is T1? Pressure, if you take it in kilopascal, 1 bar is equal to 100 kilopascal, so it will be 6500. V1 is 0.0135 upon mass is 1 into R for air is 0.2. 0.287, isn't it? What is R for air? It is 0.287 kilojoule per kg Kelvin. So this will be temperature in Kelvin. What is the value of T1? Using the ideal gas equation, what will be the value of T1? The temperature T1 will come out to be 305.75 Kelvin. Are you guys getting T1 as 305.75? Yes or no? 305.75 something, 749 something. And how to find out T2? Using the polytropic process. How to find out T2? To find T2, 1 to 2 is polytropic process. Can we say T2 by T1 is equal to V1 by V2 to the power n minus 1? So T2 is equal to, what is T1? 305.75 into V1. V1 and V2 are given. V1 is 0.0135 upon 0.1 to the power 1.3 minus 1. What is the value of T2? Find out the value of T2. Can you find out the value of T2? It must be something around 167.7. Please do let me know the value of T2. 167.7 something. Isn't it? Now you know the value of T1 and T2. Put the values in the formula for delta U. So delta U is equal to M into CV into T2 minus T1. So M is 1. CV for air will be equal to 0.718 into T2, that is 167.7 minus 305.75. This will give you the answer in kilojoule. So what is the value of delta T? It will be negative. It will be negative. Can you solve for delta T? Can you get me the answer for delta T? Are you getting minus 99.2 something? Kilojoule. Minus 99.2. B will be the answer. Yes. Very nice, Neeraj, Tushar, Maniket. B will be the correct answer. Question number 2, B will be the answer. Let us move to the next one. If anybody is having any doubt, anything to ask, you are most welcome. You can write your doubts in the comment section. I will be more than happy to help you. Question number 3 is wonderful question actually. Question number 3. From the entropy in basic thermodynamics, the question says 1 kg of steel block mass of steel block is 1 kg at 1000 degrees Celsius. Initial temperature of the steel block is 1000 degrees Celsius, is placed in contact with 2 kg of ice at 0 degrees Celsius. So ice is at 0 degrees Celsius and the steel is at 1000 degrees Celsius in an insulated container. Insulated container means Q is equal to 0. There is no heat loss to the surrounding, which reaches a final state of equilibrium. Both the steel block and the ice will reach to the final equilibrium state. Latent heat of fusion of water is 333.4 kilojoule per kg and specific heat capacity, that is Cp, for water is 0.5. It is for steel is 0.5 kilojoule per kg Kelvin. The entropy change for ice is whenever a steel block is in contact with an ice block, then what will happen? Because steel is at higher temperature, ice is at lower temperature, then the heat will be released by the steel block and will be gained by the ice. So first of all, try to check how much heat will be required to convert the ice completely into water. So heat required for complete conversion of ice into water. Can you find out the heat required for complete conversion of ice into water? Heat required for complete conversion of ice into water. So that will be mass of ice into latent heat of fusion. What is the mass of ice? That is 2 into 333.4. So ice at 0 degrees Celsius, will be completely converted into water at 0 degrees Celsius. We are trying to find out the heat required. That will be kilojoule. Isn't it? So it will be 666.8 kilojoule. That is the heat required. Heat required for complete conversion. And if we assume that, then the final temperature of the steel block will become 0 degrees Celsius. So what is the, so assume that T final is equal to 0 degrees Celsius. So ice will be completely converted into water. So we can say heat lost by the steel will be equal to heat gained by ice, isn't it? That is energy conservation. Heat lost is equal to heat gained. So what will be the heat lost? Mass of steel into specific heat of steel into 1000 minus 0, isn't it? So that is heat transfer. What is mass of steel? That is 1 kg. 0.5 into 1000. How much is that? That is 500 kilojoule. So heat transfer is equal to, if we assume the final temperature to be 0 degrees Celsius, because ice is completely converting into water, that is what we are assuming, then the final temperature of the system will be 0 degrees Celsius, isn't it? So for final temperature of the system to be 0 degrees Celsius, the heat transfer will be 500 kilojoule. So we can say this heat transfer will be less than heat required for complete conversion of ice into water. Do you agree? This heat transfer is less than 500 kilojoule, will be less than the heat required for complete conversion of ice into water. So it means there is a partial conversion of ice into water. So water is converting, the ice is converting into water. So it is a case of, so there is a phase change in ice. So we can say implies there is a phase change, and then delta S for the ice, because heat is added. So Q added upon temperature of ice, Q by T. Because there is a phase change, so temperature will remain constant, and temperature is equal to 0 degrees Celsius. So Q added is 500, and the temperature will be 0 degree Celsius plus 273. That will be the change in entropy for the ice. 500 upon 273 kilojoule per Kelvin will be the answer. 500 by 273. 500 divided by 273. 1.8315. The answer will be 1.8315. B will be the correct answer. Question number 3, B will be the right answer. I hope it is clear. This is wonderful question. Question number 4 is simple. Now, yes, Shiva, well done. Tushar, Sujata, Maniket, good. Third question, answer B. Question number 4, in an Otto cycle, that is constant volume cycle, the temperature at the end of heat supply if I draw TS curve for Otto cycle, 1 to 2 is isentropic compression, then constant pressure, constant volume heat addition, then isentropic expansion, then constant volume heat rejection. 1, 2, 3, 4. There is a heat addition here. 2 to 3 is constant volume heat addition, and this is heat rejection. So in an Otto cycle, the temperature at the end of heat supply is this. What is the end of heat supply? That is T3, 3196.2 Kelvin. And at the beginning of the heat rejection, what is the beginning of the heat rejection? T4, that is equal to 1391.3 Kelvin. Then the thermal efficiency of the cycle. What is the thermal efficiency of an Otto cycle? 1 minus 1 upon R to the power gamma minus 1, isn't it? And T2 by T1 is equal to T3 by T4 is equal to R to the power gamma minus 1, because 1 to 2 and 3 to 4 are isentropic process. So put the value of R to the power gamma minus 1, that is T3 by T4. So from here we can say efficiency of Otto cycle 1 minus T4 by T3, isn't it? Put the value, you will get the answer. 1391.3, 3196.2. That will give you the answer. What is the answer? Question number 4. What will be the answer? Question number 4. What is the answer? Is it C? Isn't it A? Sujata, Maniket, isn't it A? Mani? Everyone, please do let me know if it is A or C. Is it A or C? It will be A. Right? Option A will be the correct answer. Well done, guys. Well done. Let us move to the next one. Question number 5. I am having 20 questions in total. In an ideal gas turbine plant, inlet temperature is, gas turbine plant works on Brayton cycle. It works on Brayton cycle. If we draw TS curve, it will look like similar to Otto cycle. The only difference is they are constant pressure process. 1 to 2 is isentropic. Heat addition is constant pressure. 3 to 4 is again isentropic, and heat rejection is constant pressure process. In an ideal gas turbine plant, inlet temperature is 300 Kelvin, that is T1, 300 Kelvin. Peak temperature, that is T3, is equal to 1200 Kelvin. And the temperature drop in turbine, what will be the, this is the turbine work produced by the turbine. So T3 minus T4 is given as 480.8 Kelvin. 480.8 Kelvin. Then the compression work, if Cp is given as is. What is the compression work? WC. Compression work, because it is an ideal gas, so we can say WC is equal to, the answers are in kilojoule per kg, so mass is 1 kg. Compression work will be equal to M into Cp, or we can say it will be per unit mass, it will be H2 minus H1, isn't it? And H2 minus H1 is Cp into T2 minus T1. So we need to find out the value of T2. How to find out T2? We need to find out the value of T2. Can you find out T4 from here? T4 is equal to, because T3 is 1200, so 1200 minus 480.8. 1200 minus 480.8 is equal to T4. What is the value of T4? Are you getting T4 as 719.2? Are you getting T4 as 719.2? Isn't it? Then how to find out T2? Can we say T1 T3 is equal to T2 T4. So can you find out the value of T2? T2 is equal to T1 300 into T3 1200 upon T4 719.2. What is the value of T2? Is it 500.55? Very nice. Yes, money. 500.55 Kelvin. Once you get T2, then put the values. Put the values in the above formula. Find out the value of T2, then put the value in above formula. You will get the answer. So compression work is equal to CP is given in the question. We are supposed to use this value 1.0035. 1.0035 into T2, that is 500.55 minus T1. What is the value of T1? That is 300 kilojoule per kg. What will be the answer? Are you getting option C? 201.25. Are you getting 201.25 kilojoule per kg or not? Are you getting this or not? Option C is the correct answer. Yes, Rohan, Mani, Sujata, Manike, the more you solve, the more confidence, the more improvement you develop. So do not just wait for me to solve the question. As soon as you see the question, start solving it. And if you have any doubt, then you can ask through the comment section. Question number 6 is very beautiful and important. Consider because this is a combination of heat transfer and thermal engineering. This is the combination of heat transfer and thermal engineering. Right? Let us solve this one. Read the question. Consider a one-dimensional steady state heat conduction process through a solid slab of thickness 0.1 meter. L is equal to 0.1 meter. The higher temperature side A has a surface temperature of 80 degrees Celsius. T1 is equal to 80 degrees Celsius. And the heat transfer rate per unit area to the low temperature side is Q dash heat flux is equal to 4.5 kilowatt per meter square. That is the flux. And the thermal conductivity of the slab is 15 watt per meter Kelvin, right? The rate of entropy generation per unit area during the heat transfer process is, we need to find out the rate of entropy generation per unit area in watt per meter square Kelvin. The answer should be in watt per meter square Kelvin. Can we find out T2 first? Can we find out T2 first? By using the concept of heat transfer, can we say Q dash is equal to K delta T by L? Q dash is equal to 4.5 into 1000 is equal to K, that is 15, then T1 minus T2, 80 minus T2 upon L, that is 0.1. What is the value of T2? First of all, let me know the value of T2 in degrees Celsius. What will be the value of T2 in degrees Celsius? Find out the value of T2 in degrees Celsius. Are you getting 50 or not? The value of T2 in degrees Celsius, is it 50 or not? 4.5 into 100. It means 450. 450 divided by 15. That is 30. So T2 is equal to 80 minus 30, 50 degrees Celsius. It will be 50 degrees Celsius. Now, try to understand. Now, try to understand the concept. This is the slab, let us say. There is a heat flux Q dash. Here it is 80 degrees Celsius, that is T1. And here it is 50 degrees Celsius, that is T2. Now, this is our system. This is our system. And if we write the entropy balance equation, if we write entropy balance, so we can say change in entropy for the system. This is our system. Change in entropy for the system is equal to entropy transfer plus entropy generation. Entropy is a non-conserved property. Change in entropy for the system is equal to entropy transfer plus entropy generation. If we want per unit time, so ds by dt of the system is equal to entropy transfer is s dot I entering minus s dot exit plus s dot generation. That is per unit time. And for steady state heat flow, the entropy transfer takes place due to the heat transfer. It is a closed system. For a steady state, we can say this ds by dt of the system will be equal to 0. So if this is 0, so entropy generation per unit time is equal to s dot exit minus s dot entry. This is the expression. So entropy transfer takes place along with the heat transfer. So here the heat is leaving. So how much the entropy is leaving from the system? Q dash is constant. So can we say entropy generation is equal to Q dash by T2 minus Q dash by T1, isn't it? So it is Q dash, it will be Q dash into T1 minus T2 upon T1 into T2 will give you the answer. That is the entropy generation. So Q dash is equal to 4.5. So it is 4500, isn't it? 4.5 into 1000 is 4500. Then T1 minus T2, 80 minus 40. Then we need to take the temperatures in Kelvin here. So 80 minus 50 upon 273 plus 80, 273 plus 80, 353 into 323. So this will give you the answer watt per meter square Kelvin. This will give you the answer in watt per meter square Kelvin. Can you solve it? What will be the answer? Are you getting option A or not? Everyone, please give it a try and let me know. 4500 into 30 divide by 353 divide by 323. 1.1840. Are you getting 1.1840 watt per meter square Kelvin? Have you understood the question or not? 1.184. Did you guys understand the question? Did you understand the question? Let us move to the next one. Yes, these are some of the questions from the thermal engineering. Let us move to some of the questions for the fluid mechanics now. Yes, there is mega mock test which is already running up to 17th of November. I hope you guys are aware about that. So please do appear in the mock test, and based on your performance in this third mock test, you will be able to unlock our test series at a discounted price. Let us move to the question from the fluid mechanics. Question number 7. Quickly solve it. Question number 7 on the screen. A 40 centimeter cubical block slides on oil. Viscosity is 0.8 Pascal second over a large plane horizontal surface. There is a horizontal surface, there is a cubical block which is sliding over it. It is the horizontal surface and there is a cubical block sliding over it. If the oil film between the block and the surface has a uniform thickness is 0.4 mm. So the thickness between these two is, that is h 0.4 millimeter. What will be the force required to drag the block at a velocity of 4 meter per second? The question is from the Newton's law of viscosity. So F is equal to mu into A, surface area in contact with the fluid, into velocity, tangential velocity by H. Put the value, you will get the answer. What is the answer for question number 7? Question number 7. Viscosity is 0.8. Area will be the area of the bottom surface only. That is 40 centimeter. 0.4 into 0.4 into 4 meter per second upon thickness is 0.4 into 10 to the power minus 3. So this will give you the answer, force required. What will be the force required? Isn't it 1280 Newton? Isn't it option A? Option A will be the answer, right? It will be option A. Do not commit the mistake. The next one, question number 8. Question number 8. A nozzle has an inlet and outlet diameter of 10 centimeter and 5 centimeter. This is 10 centimeter, that is D1, and this is D2 is 5 centimeter, that is the nozzle. If it discharges air having a density of 1.2 kg per meter cube at the rate of this 0.1, discharge is equal to 0.1 meter cube per second into atmosphere. So P2 is equal to P atm. The gauge pressure at the nozzle inlet will be. So by using the Bernoulli equation, first of all, apply the continuity equation. So we can say D1 square into V1 is equal to D2 square into V2. So D1 is twice of D2. So V2 is equal to 4 times of V1. V2 will be equal to 4V1, isn't it? If you apply the continuity equation, V2 will be 4V1. Then Bernoulli equation. Then apply the Bernoulli equation. In terms of pressure, we can write P plus rho Gz plus P1 plus rho G P1 plus rho G Z1 plus rho V1 square by 2 is equal to P2 plus rho G Z2 plus rho V2 square by 2. If we want gauge pressures, so P2 gauge will be 0. The nozzle is horizontal, so Z1 is equal to Z2. So the question is to find out P1 gauge. So P1 gauge is equal to rho by 2 into V2 square minus V1 square. V2 is equal to 4V1. So rho by 2 into 16 V1 square minus V1 square. So P1 gauge will be equal to 15 rho V1 square by 2. Now we need to find out V1. What is V1? That is 4Q by pi D1 square. What is the value of V1? 4 into 0.1 upon pi into D1 is 10 centimeter. So 0.1. 0.1 getting cancelled out. So what is the value of V1? Can you find out the value of V1? $12.73. V1 is 12.73. Maniket, 0.01 क्या चीज होगा? Put the value here, then you will get P1 gauge. 15 rho is 1.2. Density is 1.2 into V1 square 12.73 square upon 2. What will be the gauge pressure in Pascal? This will give you the answer in Pascal. So 12.73 square into 15 into 1.2 divided by 2. So it will be 1.46 kilopascal, 1459.02 Pascal, and it is 1.46 kilopascal. It is around 1.46 kilopascal. Are you getting it or not? 1.46 kilopascal will be the answer. This is question number 8. This is question number 8. Let us move to question number 9. Question number 9. Water flows from an open vertical cylindrical tank. There is a vertical cylindrical tank and there is a water flowing of 20 centimeter diameter. Capital D is 20 centimeter through a hole of 10 centimeter diameter. So small d is equal to 10 centimeter. What will be the velocity of water flowing out of the hole? What will be the velocity of the water which is flowing out of the hole at the instant when the water level in the tank is 50 centimeter above the hole? Can you find out the answer? This is 50 centimeter. This is the free surface. This is H is equal to 50 centimeter. Can you solve it? Everyone, please give it a try. Quickly solve it and let me know the answer. Question number 9. Question number 9. यहां पे स्टूडेंट ये मिस्टेक करते हैं. हियर द डायमीटर ऑफ द टैंक इज नॉट वेरी वेरी लार्ज. इफ यू अप्लाई कंटिन्यूटी इक्वेशन, please give it a try. What will be the answer? Yes, tell me. If you apply continuity equation, can we say d1 square into v1 is equal to d2 square into v2? So here v2 is equal to 4 times of v1, isn't it? Because capital D, diameter of the tank is twice of diameter of the hole. So v2 is equal to 4v1, or we can say v1 is equal to v2 by 4. Now if we apply the Bernoulli equation, between 1 and 2, P1 is equal to P2 and Z2 is equal to 0, Z1 is equal to H. So if we apply Bernoulli equation, P1 by rho g plus Z1 plus V1 square by 2g is equal to P2 by rho g plus Z2 plus V2 square by 2g, right? P1 and P2 are equal, Z2 is equal to 0, Z1 is equal to H. So we can say V2 square minus V1 square is equal to 2gh. Put the value of V1 because the question is to find out V2. So what is V1? V1 is equal to V2 by 4. So we can say V2 square minus V2 square by 16 is equal to 2gh. So V2 is equal to 2 into 10 into h. What is h? H is 50 centimeter. So 0.5 up into 15. Isn't it 15? it is 16 by 15 and then under root. This will be the answer. This will give you the answer. 20 into 0.5, that is 10. (160) divided by 15. Take the square root. It is 3.2659. 3.2659 meter per second will be the value of V2. What is the answer? It will be 3.26. It will not be 3.16. It will not be A, Shiva, Maniket, Tushar, Mani. It will not be A, it will be B. B will be the answer. B will be the correct answer. Let us move to the next one. This is simple. Question number 10. Question number 10. In the manometer shown in the figure, the pressure PA of the gas, there is a gas in the bulb, is approximately in terms of bar. Options are in terms of bar. So because there is a gas in the bulb, so this height becomes negligible. So we can say here the pressure is assumed to be PA. And this is the datum line. This is the line where the pressure will be same. If we write the pressure equation, so PA plus the fluid is water. This is water. So rho of water into G into this distance will be 10 centimeter. Total is 30. This is 20. Then this will be 10. 10 centimeter, that is 0.1. is equal to P ATM plus here it is mercury, rho of mercury into G into 30, that is 0.3. So PA absolute will be equal to P ATM, that is 1 bar, 1 plus G, let us take approximately, it is asking, then you can take G as 10 meter per second square. Put the value of G as 10 meter per second square. So 1 plus density is 13.6 into 10 into 0.3 divided by 1000 minus 1 into 10 into 0.1 divided by 1000. That will be so how much is that? 1 plus 0. Can you solve it? 13.6 divided by 13.6 into 0.3 divided by 100, 0.0408 minus how much this will be? 1 by 1000, 0.001. So 1 plus 0.0408 minus 0.001, 1.0398, that is 1.0398 bar. Take care of the unit. Option C is the correct answer. It is almost 1.4 bar. 1.039. It is almost 1.4 bar, isn't it? C will be the answer, not B. It will be C, 1.039. So we are halfway now. Some more questions. Question number 11. Consider a fully developed laminar flow in a circular pipe. If the diameter of the pipe is halved, D2 becomes D1 by 2. While the flow rate and the length of the pipe remains constant, Q and L remains constant. Then the head loss will increase by a factor. So can we say HL is equal to FLQ square upon 12.1 D to the power 5? We need to develop a relation between HL and Q and L and D. Length is same, diameter is constant, sorry, not diameter. Length is constant, Q is constant. 12.1 is constant. So we can say HL is proportional to F by D to the power 5. But for a laminar flow, F is equal to 64 by Reynolds number. Very, very important. So F is equal to 64 mu by rho Vd. 64 is constant, mu is the property, rho is the property. So we can say F is proportional to 1 by Vd. And because Q is constant, that is pi by 4, D square into V is constant. So V is inversely proportional to D square. If you put the value here, then we can say F is proportional to D. F will be directly proportional to D. F will be directly proportional to D. So we can say HL is proportional to F by D to the power 5. That is HL is inversely proportional to D to the power 4. HL will be inversely proportional to D to the power 4. That is important. Or you could have used this approach for a laminar flow. We can say HL is equal to delta PL by rho G. So that is 1 by rho G. Delta PL is 32 mu VL by D square. So from here you could have said HL is proportional to rho is constant, G is constant, mu is constant, length is constant. So V upon D square. And here V is inversely proportional to D square. So we could have said HL is inversely proportional to D to the power 4 for laminar flow. This is called as Hagen-Poiseuille equation. This is called as Hagen-Poiseuille equation. So the correct answer is option C, not option D. Beautiful question. That is where students commit mistake. The answer to this question is option C. I hope it is clear. Tushar, Mani, those who are giving me the answer as D, C is the right answer. I hope it is clear. The next one. The next question is simple. Question number 12. The loss of head in a pipe of 100 meter length, that is length, carrying oil, volume flow rate of 100 liter per second is estimated to be HL. If a pipe of double the diameter, D2 becomes twice of D1, but of the same length remains constant, is to carry the discharge of 200 liter per second. Q1 was 100, now it is 200. Then the head loss will be, because it is nothing is mentioned regarding the laminar or the turbulent nature of the flow. So we will assume F to be constant here. In this question, F will be taken as constant, but when the question is specifically mentioning that the flow is laminar, then F will not be taken as constant. Are you getting it? So that is what you need to take care. HL is FL Q square upon 12.1 D to the power 5. Length is constant, F is taken as constant. So HL is proportional to Q square upon D to the power 5. So here we can say HL2 is equal to HL1 into Q2 by Q1 square into D1 by D2 to the power 5. D1 by D2 is equal to 1 by 2. Q2 by Q1 is 2. So it will be 2 square into 1 by 2 to the power 5. What will be the answer? Isn't it HL by 8? Isn't it HL by 8? D will be the answer for this one. For this question, D will be the answer. Previous question, F cannot be taken as constant. That is what you need to take care from the language of the question, right? The next question, question number 13, from the external flow. Question number 13, the ratio of turbulent boundary layer thickness to the thickness of laminar boundary layer. Turbulent to the laminar boundary layer thickness ratio. So for laminar, boundary layer thickness for laminar is proportional to x to the power 1 by 2. For turbulent, it is x to the power 4 by 5, isn't it? So turbulent by laminar will be x to the power 4 by 5 upon x to the power 1 by 2. So x to the power 4 by 5 minus 1 by 2. What will be the answer? X to the power 8 minus 5, that is 3 by 10. X to the power 3 by 10. D will be the answer. D. It will be D. It will not be 10 by 3. It will be 3 by 10. It will be 3 by 10, isn't it? Turbulent by laminar is the question. The question is about turbulent upon laminar. Turbulent upon laminar. Question number 14. Few more questions. Yes, everybody please give it a try. This is simple. The equation of the streamline passing through the point 1, 1. This is simple. Can you compare it with the general velocity profile? Then u is equal to ax, v is equal to minus ay. Differential equation of the streamline is dy by dx is equal to v by u. What is v? That is minus ay. Then it is a into x. A getting cancelled out. Separate the variables. We can say dy by y is equal to minus dx by x. Then integrate. Just give me a moment. Yes. So integrate this. Then ln of y is equal to minus ln of x plus c, or we can say ln of y is equal to ln of c by x. Natural log will get cancelled out. So xy is equal to constant at 1, 1. C is equal to 1. So our expression will be xy is equal to 1 will be the equation of the streamline. 14C, well done. 14th answer will be C. Solve question number 15. In a certain fluid through a 200 mm diameter pipe, the shear stress at the boundary is 10 Pascal. It is from the internal flow. The shear stress at the boundary, that is 10 Pascal. The loss of head due to viscous friction in 0.1 kilometer length of the pipe is HL. That is delta PL by rho G, isn't it? HL is equal to delta PL by rho G. And how to calculate delta PL? That is equation number 1. So can we say tau naught is equal to delta PL by L into R by 2 or D by 4? Valid for laminar as well as turbulent. So we can say delta PL is equal to 4L tau naught upon D. 4 into what is the length? 0.1 kilometer, that is 100 meter, into tau naught, that is 10 upon diameter 200 mm, 0.2 meter. What is delta PL? What will be the value of delta PL? It will be 2 into 10 to the power 4 Pascal, isn't it? 20,000 Pascal. Delta PL will be 20,000 Pascal. Put it in equation number 1. So HL is equal to 20,000. The fluid is water. If nothing is mentioned, or the options are, so it is 20,000 Pascal. So it is not 20 Pascal. It is not 200 Pascal. 20,000 Pascal will not be 2 bar. It will be 0.2 bar, isn't it? So if you check this option, rho is 1000 into 10. So it is 2 meter of water. It will be 2 meter of water. B will be the answer. B will be the correct answer for question number 15. Question number 16. That is from the external flow over a flat plate. The length of the laminar part of the boundary layer on a smooth plate is 25 centimeter. Laminar part of the boundary layer. That means the critical value of critical length is equal to 25 centimeter. If the viscosity of the fluid is 0.1 stroke, that is the kinematic viscosity. What is the velocity of the free stream of water? We need to find out free stream velocity. So the critical Reynolds number is equal to 5 into 10 to the power 5 is equal to u infinity into critical value of x upon kinematic viscosity. So the question is to find out u infinity. Can you find out u infinity? 5 into 10 to the power 5. Kinematic viscosity is 0.1 stroke into 10 to the power 5 minus 4. Isn't it? Upon critical value of x, 25 centimeter, that is 0.25 meter. That will give you the answer. What is the answer for question number 16? Question number 16, what will be the answer? Are you getting option D? Yes, well done. D. Sujata, it will be D. Shiva, good. Tushar, Maniket, D will be the answer. So these are some questions from the fluid mechanics. They must be, couple of questions must be a little tougher, but if your concepts are clear, you will be able to solve these questions. I will share the PDF of this session to my Telegram channel. You must be aware that at 7:30 p.m. there will be a workshop taken by Richa ma'am for GATE 2025 aspirants. So do not forget to join this workshop if you are targeting GATE 2025. And there will be scholarship test on this Sunday, 19th of November, anytime between 9 a.m. to 9 p.m. Right? Let us move to the next question. Question number 17. This is from the heat transfer now. The question is from the heat transfer. The heat generated in a solid sphere. It is a sphere of radius r is q dot watt per meter cube. That is the rate of uniform heat generation per unit of volume. The constant heat flux q. Flux is watt per meter square from the surface of the sphere is. So we can say, if we apply the energy equation, we can say whatever the heat generation is equal to heat leaving from the sphere. Whatever the heat generated will be equal to heat leaving from the sphere. So heat generation will be equal to q dot into volume 4 by 3 pi r cube is equal to flux, that is q, into area 4 pi r square. So q generation is q dot into volume is equal to q into surface area available for heat flow. So q can be calculated as this. This is the flux. It is actually q dash. So it isn't it q dot r by 3. Volume upon surface area is r by 3. Volume of sphere upon surface area is r by 3. Volume of sphere upon surface area of sphere is r by 3. So it is q dot into r by 3. C will be the answer. C will be the answer. Question number 18. A long solid cylinder, surface 1 of diameter d1 is enclosed by another long concentric cylinder. There is a cylinder d1 is enclosed by another cylinder d2. Inner cylinder is insulated from inside and outer cylinder is insulated from outside. This is the arrangement. It is the cylinder, not the sphere. If d2 is equal to twice of d1, the percentage radiation from surface 2 to itself, F22 is how much? This can be treated as enclosure. This can be assumed as enclosure, two surface enclosure. So we can say F11 plus F12 is equal to 1. F11 is equal to 0 because it is a convex surface. So F12 is equal to 1. Similarly, F221 plus F222 is equal to 1. So from here we can say F222 is equal to 1 minus F221. And F221 can be written by using the reciprocity theorem. F122 is 1. So F222 is equal to 1 minus A1 by A2. Or we can say that is equal to 1 minus pi D1L upon pi D2L. Pi L getting cancelled out. So 1 minus D1 by D2. What is D1 by D2? That is 1 by 2. That is equal to 0.5. 50%. 18C. Yes, Shiva. 18. Option C is correct. F222. F121 is 0. F222 is equal to 50%. Second last question. Question number 19. Question number 19. A steel plate is exposed to solar heat flux of 800 watt per meter square. There is a steel plate which is exposed to solar heat flux of 0.800 watt per meter square. This is the sun. So Q is equal to, or Q dash is equal to 800 watt per meter square. Now the plate is exposed to the air. This plate is exposed to air at 30 degrees Celsius on both sides. Here there is an air, here there is an air. The temperature of air is 30 degrees Celsius, this is 30 degrees Celsius. The convective heat transfer coefficient is 10 watt per meter square on the back side. H is equal to 10 watt per meter square Kelvin. Here H is equal to 15 watt per meter square Kelvin. The equilibrium temperature of the plate, let me call the equilibrium temperature to be Ts. So whatever the heat is entering should be leaving from both the sides, isn't it? So if we write the energy equation, Q in must be equal to Q out. What is heat entering? That is 800 is equal to 10 into Ts minus 30 plus 15 into Ts minus 30. Can you find out the value of Ts? What will be the value of Ts? Can you find out the value of Ts? I will share the PDF of this session to my Telegram channel. This is question number 19. Isn't it 62? Are you getting 62 or not? 62 degrees Celsius will be the answer. Will be the answer. Now the last question. Question number 20. The center to the surface temperature difference in a heat generating cylindrical rod of diameter 8 cm is 30 degrees Celsius. There is a heat generation in a cylinder. So Ts or T maximum for a cylinder is equal to Ts plus Q dot R square by 4K. So this difference delta T for a cylinder, that is equal to T maximum minus Ts is equal to Q dot R square by 4K. That is 30 degrees Celsius temperature difference. Under similar conditions, the center to the surface temperature difference in case of a sphere is, for a sphere, T maximum for a sphere will be equal to Ts plus Q dot R square by 6K. So we can say delta T for a sphere is equal to Q dot R square by 6K, isn't it? So delta T for a sphere upon delta T for a cylinder is equal to Q dot R square by 6K divided by Q dot R square by 4K. So isn't it 4 by 6? That is 2 by 3. So for a cylinder, so what is delta T for a sphere? That is equal to 30 into 2 by 3 degrees Celsius. 30 into 2 by 3. 30 into 2 by 3. How much is that? 60 by 3. 20 degrees Celsius. B will be the answer. Alright, so that is all from my side. Today or tonight at 7 p.m. I will be having this practice session for GATE BYJU'S 90s questions for heat transfer. Today at 7 p.m. Do not forget to join me today at 7 p.m. on the YouTube for this practice session GATE BYJU'S. Early 90s questions we will discuss. All right, and you can download the app also, because there are practice sessions going on in the app as well. So if you have not downloaded the app yet, please do download the app using this bit.ly link. In each of my YouTube session description box, you will find this link that is called as bit.ly link. By clicking this bit.ly link, you can download the BYJU'S exam prep app and start practicing some wonderful questions on the app as well. So that is all from my side, guys. Thank you very much for joining in. If you are targeting at 2025 or 2026, we are running, or we have started a long-term batches for 2025 and 2026 aspirants. If you want to know more about these paid courses, you can call the number, you can give a missed call, or you can give a call to the mentioned number. You can talk to the counselor for more details. All right, and this is my link to join the Telegram. So thank you very much, guys. Have a good day. Take care. See you in the next mock test. Till then, enjoy and keep preparing, keep working hard. The success will be all yours. Thank you and Jai Hind.